Hello everyone. Today we have discussed about transmission line protection. I am Mr. Ajit, Assistant Professor in School of Electrical and Power Engineering at Anand International College of Engineering, Jaipur. Transmission line protection. Under the transmission line protection, we have discussed about distance relay. Next, introduction to distance protection. Distance protection is used to provide protection of transmission line during a fault in the line. Distance relay are used to provide distance protection which measure the impedance between the relay location and the point where the fault is incident and compare it with the set value of impedance. If the measured impedance is less than the set value, the relay operates and isolate the faulty section. Now we have see about distance relay. Distance relay are actually double equating quantity relay with one coil energized by voltage and the other coil by current. The current element produces a positive or pickup torque while the voltage element produces a negative or reset torque. Under this, only a fifth type of relay will be considered here. They are number 1 impedance relay, number 2 reactance relay, number 3 Moore relay. First, impedance relay. In the normal operating condition, the value of the line voltage is more than the current. But when the fault occurs on the line, the magnitude of the current rises and the voltage becomes less. The line current is inversely proportional to the impedance of the transmission line. Thus, the impedance decreases because of which the impedance relay start operating. Consider the impedance relay is placed on transmission line for the protection of line AB, that is our bus A, that is our bus B. In between this A and B bus, we have a transmission line. In this transmission line, a CT provide current and PT provide voltage to the impedance relay. The Z is the impedance of the line in normal operating condition. If the impedance of the line fall below the impedance Z, then the relay start working. Let the fault occur in the line AB. This fault decreases the impedance of the line. Below the relay setting impedance, the relay start operating and it's send the tripping command to the circuit breaker. If the fault occurs beyond the positive protective zone, the contacts of the relay remain inoperative. Here are the characteristics of an impedance relay. The operating characteristics of an impedance relay on voltage current diagram is shown in the figure. Here this is voltage axis, this is along x-axis we have considered our voltage axis, along y-axis we have considered our current axis, and that band is due to our यहाँ पे जो spring torque की वजह से, and that is our operating region. In between this line and current axis we have considered this is as a operating region and this is our non-operating region. If the characteristics of the relay lies in this region, then the relay should operate, otherwise in this region the relay will not operate. Normally the operating characteristics of distance relay are shown on an impedance diagram or RX diagram. This is clear from the characteristics that if the impedance as seen by the relay lies within the circle, the relay will operate. This is in RX diagram. Along x-axis we have considered the resistance, along y-axis we have considered the reactance value, and that is our RX diagram characteristics of impedance relay. If the line impedance under fault condition lies within this circle, then the relay operate. If the impedance value lies outside the circle, then the relay should not operate. The impedance relay normally used a high speed relay. This relay may use a balance beam structure or an induction cup structure. Next, this is our directional property to the impedance relay can be given by using the impedance relay along with a directional unit, as is done in case of a simple overcurrent relay to work as a directional overcurrent relay. This means the impedance unit will operate only when the directional unit has operated. The characteristics of such a combination will be as shown in the figure. In this figure we have the directional characteristics of impedance relay. From the characteristics it is clear that if the impedance vector as seen by the relay lies in a zone indicated by the thick line, the relay will operate, otherwise it will not operate. It means if our impedance lies in this region, then the relay will operate. If our impedance lies in this region, then the relay would not operate for that. Next one is the reactance relay. In this relay, the operating torque is obtained by current and the restraining torque due to a current voltage directional element. This means a reactance relay is an overcurrent relay with directional restraint. The directional element is so designed that its maximum torque angle is 90 degree. If we consider tau is equals to 90 degree in the universal torque equation, then the reactance relay have a torque equation T is equals to K1I square minus K3 VI cos theta minus tau. Here this component of the equation provide operating torque and this component of the equation provide restraining torque. Here if we take tau is equals to 90 degree, then it will become theta minus 90 degree, and cos theta minus 90 we have replaced by sin theta. Then for the operation of the relay we have the condition K1I square is greater than K3 VI sin theta. If we modify this, then we have convert in Z sin theta is less than K1 upon K3, and Z sin theta represent our reactance value. So we can say that if reactance X is less than K1 upon K3 constant value, then the relay operate, otherwise the relay would not operate. The structure used for the reactance relay are induction cup structure, double induction loop structure. A typical reactance relay using induction cup structure is shown below. It is a 4-pole structure. This has operating, polarizing and restraining coils. The operating torque is produced by the interaction of the flux due to the winding carrying current coils. For example, interaction of flux of pole 1, 2 and 3, that is first pole, that is second, that is third pole. And the restraining torque is developed by due to the interaction of the flux due to the pole, first pole, third pole and fourth pole. The operating torque will be proportional to I square and the restraining torque proportional to VI cos theta minus 90 degree. The desired maximum torque angle is obtained with the help of RC circuit as shown in the figure. This circuit is generally used to get the desired torque angle. That is the characteristics of reactance relay. This means for the operation of the relay, the reactance seen by the relay should be smaller than the reactance for which the relay has been designed. The characteristics will be as shown in figure. In this figure, the characteristics of reactance relay is represented. This means if the impedance vector head lies on the parallel line R axis and the operating characteristics, this will have a constant X component. It means if we have a resistance value for a constant X value, then this straight line represent our the various resistance value at a constant X value. The important point about this characteristics is that the resistance component of the impedance has no effect on the operation of the relay. It responds only to the reactance component of the impedance. The relay will operate for all impedances whose heads lies below the operating characteristics, whether below or above the x-axis. If our reactance value lies below this line, then the relay operate. Resistance value does not affect on the characteristics of the relay. We have minus R to plus R anywhere for any value of resistance If we have the reactance value less than this region, then the relay operate. If our X value is greater than this region, then the relay not operate. More relay. In this relay, the operating torque is obtained by the VI element and restraining torque due to the voltage element. This means a Moore relay is a voltage restraint directional relay. From the universal torque equation, we have the torque equation T is equals to K3 VI cos theta minus tau minus K2 V square. That component provide the restraining torque and that component provide our operating torque. For the relay to operate, if this component is greater than the voltage component, then from this we have modify the equation, and this is convert in the form of V by V cancel V upon 1, that is Z component is less than K3 by K2 cos theta minus phi. Moore relay. A typical Moore relay using induction cup structure is shown below. The operating torque is produced by interaction of flux due to the pole 1, 2 and 3 and restraining torque due to the pole 1, 3 and 4. That is the diagram for the Moore relay. That is restraining coil अपना, that is polarizing, that is operating. Characteristics of Moore relay. These characteristics, when drawn on an admittance diagram, is a straight line passing through the origin, and if drawn on an impedance diagram, it is a circle passing through the origin as shown in the figure. The relay operates when the impedance seen by the relay falls within this circle. The relay is inherently directional, so that it needs only one pair of contacts, which make it fast tripping for fault clearance and reduce the volt ampere burden on the current transformer.